Hello everyone and welcome to Handmade here, the show where we code a complete game live on stream. No engines, no libraries, it's just us. And what we're doing right now actually is we are finishing up some work from Friday. We had dropped our sound mixer into SSE, but we didn't have a chance to do the inside of the loop. Largely because I completely forgot how 2's well, I guess I didn't forget how 2's complement worked. I forgot how chip adding worked for some reason. And so we kind of went down a little rat hole of me remembering. And I guess the good news is that I did remember and was able to show what I was trying to show on the stream, but the bad news is that took way too long. And so basically Friday's stream, instead of being about writing a SSE mixer, actually was mostly about me not remembering a bunch of stuff from when I was a little baby. Anyway, and if you didn't see that episode, you should check it out. I actually did draw a little baby me. It wasn't a good drawing, but it was a drawing nonetheless. So anyway, what I'd like to do today is pick up where we left off. It is extraordinarily swelteringly hot here in Seattle, as it tends to get in the summer. So I am going to be sweating this entire program. And so I think we just want to focus on writing the SSE and getting it done as soon as possible and trying to ignore the fact that we are overheating because honestly, if the more I think about it, the more uncomfortable I will be. So that said, let's go ahead and remind everyone that today is day 145. So if you want to follow along at home, you want day 144's source code. And that is what I am starting with here. So, you know, keep it in mind. So yeah, the way that we had left things, nothing particularly broken. Everything still works the way that you would expect. You know, our sound mixer code is still running, playing music and other things. But we did not quite finish with the SSE part of it, and so there's a bunch of things that we want to be able to do there that we have not done. So I'm going to go ahead and get that going. The first thing that we want to do is finish up that inside loop with SSE, and then I'm assuming that what we would like to do as well, in addition to just keep everything nice and simple in this mixer code as we're writing it, is we'll probably want to change our sort of thinking elsewhere in the application to think of 4 samples as 1 sample, so that we know that everything's always going to be aligned. Because right now we allow things to basically be on individual 16-bit sample boundaries per channel, and I think what we would like to do probably further on down the line is think of things in terms of either 4 or 8 samples even, perhaps. And the reason that I say 8 samples is because 8 samples in 16-bit obviously would be one full width register. If you think about, you know, 16, right, times 8 of those is 128 bits, which is the width of those SSE2 registers. And so we may want to go ahead and do it that way, just to make it a little bit cleaner, right? So what I'm going to do first is I'm going to go ahead and write this routine, pretending that we can do anything like that we want, but without actually doing it. And then we will sort of bubble back up again to the code outside and you know, make that work, right? So if you take a look at here, you know, I've got sample count align 4, and we go ahead and do that sample count align 4 stuff. So what I could do here is change this and say we actually want to do sample count align 8, meaning that we expect sample buffers to always be aligned to 8 samples instead of 4, and we could even make our own little you know, alignment code here for those. In Handmade platform, I think is where those guys actually live, right? We could make a line 8 here, something that's, you know, just aligns values to 8, like so. So if we want to, we could just say, you know what, there's always going to be a multiple of 8 samples, and that's just a requirement now. So when you call output playing sounds, you just have to give it that. And so I feel like that's the easiest thing to do. And if for some reason you really don't want that, meaning you really need something else to happen, then I guess you would modify this routine. But I feel like that's what I would like to see happen, if that makes sense. So let's go ahead and make it that way. And I'm going to go ahead and allocate these guys. So if we have sample count 8 here, what that means is that our real channel buffers will have to be a little bit bigger, right? They would have to be larger. They'd have to be twice the size of whatever the sample count 8 is, right? And what I could do is also say that, you know, I could have the sample count 4 here as well, which is just going to be 2 times that sample count for these other guys. And I don't know how, this is always kind of annoying with SSE. C just isn't really that equipped to handle it. No languages really are. It's really more of a metaprogramming thing where you kind of want lots of different conceptualizations of sort of the width of that things work at. But for we'll muddle through it, and usually it just means there's a little bit more debugging time, because usually you make a mistake somewhere with one of these counts, and then you're like, So it's not really a huge deal, but it just means it's a little bit more inconvenient, a little more stumbly as you kind of go through things. So all right, I guess actually these are the same. These are still sample count 4, right? These guys are all cleaning out sample count 4, so they're going through and they're just clearing out those real buffers. Then we go in here, right? As we pull these things in, and we're going to iterate over samples in here, what we'll do is we'll lock these guys to sample count 8, and then when we come through down at the bottom, we're still using sample count 4. Although actually, so I guess at the bottom we wouldn't want to do that. The bottom we do want to use sample count 8, because what we'd like to do is, well, no, I guess that's not true. I guess since we're writing in LR0 and an LR1, then that's fine. So I think the only person who really needs to worry about 8 wide loads is going to be in here, where we're loading from channel buffers that have 8 that are packed 16s that are not interleaved, right? So yeah. So let's see here. Let me go ahead and see if this runs at all. Yeah. So that's fine, even though right now we're not actually doing the work of making sure that actually does do the alignment. I guess we could make sure that that's going to happen by going into Handmade Win32. Let's see here. Oops, code Win32. And sample count is presumably already being, or are we actually doing this yet? Bytes to write, game get samples. So it looks like we are not yet actually, we're giving it the sample count. So I guess the only thing we really did was we just made sure that when we allocated the size of the thing, we used maximum possible overrun here to make sure we had room for it to kind of write over. But that's not, that's not really what we want it to do at the end of the day. That's really not really correct. And the reason that I say that is because we always want the number of samples we actually ask for to line up with this. So I think that's something that we kind of need to do here. So we do want to make sure that we have extra room there, perhaps, for overrun things, although I don't know that that's strictly necessary either. But basically what we want to be able to do, in fact, I really don't know that this code, I don't know really why I put this in here. Maybe it was just because it was a stupid day like before, but really we could say, remove max possible overrun, because I don't think that's really necessary. What is more necessary is in here when we're actually doing sort of this work where we're trying to figure out how many samples we want to write. You can see that we've got this bytes to write value here, right? And bytes to write is computed by figuring out where we want that target cursor to be, right? And the problem that we have is that bytes to write might not line up on an 8 sample boundary, and we want it to. So I think what we would rather do, right, is we would rather force that down to, whatever the next lowest power of 8 actually was, and that's how much we would, I'm not the lowest power, the next lowest multiple of 8. So I'm just going to take a quick scan through here. This code obviously isn't just test code. We haven't shipped a Win32 platform layer, but I just want to go through and look at it here. We look at bytes to lock. We look at how many things we expect to have till the flip. We see where the safe write cursor is, and we see whether or not we would hit it. We try to determine whether or not it's a low latency audio situation. Assuming it is a low latency one, we take a look at where we should write it. Otherwise, we just put it at the safe location. And that target cursor is where we are thinking that I guess we would like to leave our writes at, right? Okay. So let's see here. So if the byte to lock is greater than the target cursor versus not, so it looks like normally this is the case where we're not wrapping, whereas this is the case where we are wrapping, right? And it's going to do 2 writes. So I think all we would really have to do here is make sure that when we actually do this bytes to write, that we're going to round it, right? And the only reason I'm not sure about that is because I'm not sure. I don't remember what happens when we actually go to output the audio back in there. So what I want to do is see when we do Win32 sound buffer what happens in there. As long as Fill sound buffer can accept any value for bytes to write, then I think we're fine. And it looks like it does. So that looks like that's just totally fine. And if we take a look here, it looks like it also updates sort of the samples here for us. The sample count, unlock. Well, so how does it know though? So I guess it doesn't actually. All right. Well, I think we're okay though. I think that should probably be fine because we don't ever actually ask for that. So yeah, that's fine. So yeah, so what we want to do here, I think, is just take bytes to write and make sure bytes to write ends up getting rounded up, essentially. So what we want to do is say, okay, bytes to write minus divided by the bytes per sample is how many samples we want to write. What we want to do is we want to align that to the 8 sample boundary, right, to make sure that we're actually going to do an 8 sample boundary. And then what we want to do is change bytes to write back to whatever it would have been, right, if it had come out correctly in the first place, right, like this. And so we're just going to go ahead and actually just force that value to always be aligned by 8. And so then what I can do there is I can, instead of doing this now, I can just assert that this is always going to be true, right? I can just say, you know what, this sound buffer always has to play in chunks of 8. That's just a requirement. So we can just assert that, you know, those bottom bits are never set, right, of the sample count. So I think that should be good. Let's find out. Seems pretty reasonable. And so what I'd like to do in addition now is I'd like to go ahead and ensure that sounds themselves always get updated in multiples of 8 samples. And that's actually not difficult to do in terms of the way that we structure the code here, with the exception of the fact that this samples to mix thing is all in terms of individual samples, and that's kind of a little bit of a mistake, right? What we want to do is think of all of these values in terms of multiples of 8. And similarly, what we could do in here when we talk about loaded sounds and that sort of stuff, so if we go into, you know, Handmade asset.h, if what we do here is just say sample count 8, we could say, note, Casey, this is the sample count divided by 8. What we could do is just make absolutely everything always work that way. Meaning, no matter what the sound is, it has to be sort of in that sort of chunked, you know, in that chunked. It has to line up on those 8 boundaries, right? That's just a requirement that we're going to say that you have to do. And you know, that might create some problems for people who want to make looping sounds, right? But I've never been a huge fan of doing looping sounds anyway, if that makes sense. I kind of hate looping sounds. I try very, very hard to never actually use looping sounds and instead just compose lots of overlapping sounds to make things that go on forever. Because looping sounds just, you hear it, you know, you hear it. So I don't care about giving that up at all. Other people might, and they could make a different decision there. I would not hold it against them, but you know, my code base, my rules. So I am totally fine with not having any looping sounds at all, because as far as I'm concerned, I don't ever want to hear a looping sound ever, pretty much. All right, so let's see here. If we have sample count 8 instead of sample count, you can see what we were doing here is we were actually taking a look at how big the data was, and then we were doing this sort of copy here. And so what we need to be able to do is we need to be able to change this here so that in the case where we load a file which might have had more, not a multiple of 8, which is probably fairly common, just randomly, we want to pad it out, basically. So when we do all this, right, you can see us doing it here. We set all this stuff up where we create, whatever we need to create. We do the deswizzle and all that sort of stuff, right? And, we sort of swap that sample data out. And it looks like we're just doing that essentially in place, right? We're totally keeping that sample data entirely in place at the moment. And so what we want to do is just go ahead and force that out to 8. Now that's a little tricky because in this case we don't really know, since the file, it's almost like, I think in this case we would probably want to allocate some additional space and copy the stuff in, but it's kind of annoying to do that just because if we were to do that, if you think about it, once we have these things preprocessed in an asset file, there wouldn't be any need for that. So we'd be introducing something in here that's sort of an artificial need that this thing has, which is the ability to allocate memory. And I don't want to make that be something that people are thinking about, meaning I don't want to be thinking about that as we're doing the work on stuff here. So what I'd rather do, I think, is just, again, cheese it out here and assume that we can just pad out, and if we have to, we can always make sure that there's padding on the end of debug platform read entire file or something to make sure that we don't have overruns. But what I want to do is make this work as closely as possible to how it would be working in terms of engine requirements to when we actually have everything preprocessed properly, right? So what I want to do here is just say, okay, when we load in this stuff, it looks like, let's see, it looks like what we would want to do here is just at the end, we would want to pad it out if the sample count was not correct. So basically, in here we've got a sample, pad samples, and pad samples is just going to be the result sample count, whatever that was. It's going to be a line 8 of that, and minus, the actual sample count. I guess the other way we could do it is just do sample count 8 equals a line 8, like so. And then we could say that we're going to set the sample count to that, and all we need to do here is just make sure that we set those ending samples to 0 for all of the channels that actually exist, which of course I think only one channel can exist at the moment. So I don't even know why we're bothering, but that's a separate issue. Okay. All right, so what we want to do here is say for each channel, we want to go over sort of the samples that are missing, if that makes sense. We want to say that from the sample count 8, or I should say sample count align 8. Right. From sample count align 8, I want to go from there up to, or I should say, that was a slight misspeak there. I want to go from whatever the sample count was to the new aligned 8 sample count, and I want to just stick into the actual sample area. I want to stick in the zeros that we would need to pad it out. And then when we're done, we would just set the sample count equal to sample count align 8, right, like so. But since we want to store this, I think, as sample count 8, which is the divided version, we would go ahead and divide that by 8, right? And so then what I'll do here is take result sample count and turn that into just an actual thing instead of using result sample count, since there is no result sample count anymore. It's only sample count 8. So changing all of these, to sample count, which is now a local thing. And then in here, right, we just still use sample count everywhere. Let's see here, sample count, sample count, sample count, and then at the end is the only place now that we would set it, right? That's about it, I think. Let's take a look. Okay. So now that we know that the sample counts are always aligned to 8, then we should now be able to do just about everything in that aligned, in the math where everything is divided by 8, which is what I would like to be doing, so that just everything is in these little 8 wide chunks. So let's see how we would do that. Total samples to mix, right? What we want to do is for total samples to mix, we're going to be using that sample count 8, that's how many we're starting with. We're assuming we're doing the whole buffer, right? And now we're also going to be, well, I guess we'll do one thing at a time. So I'll still use these things as reals for now, and then we'll switch up later. So total samples to mix is now total samples to mix 8, right? And so what we want to do is sort of propagate that change through. Again, I'm using the fact that I'm adding the 8 to the end to show me all of the places it was used and kind of guide me through the process of updating everything that would therefore need to be updated, right? So in here now we have a real sample remaining in sound. Again, this is going to be by 8, I guess. And we would say that there's the sample count for the loaded sound. It's going to be 8, and we're going to take a look at the samples played, which is also going to be by 8, right? Let's see here. You know, there's going to be something that's going to be kind of tricky here. Now that I think about it, which is that the pitch shifting, which wants to go in the middle of samples, is going to force us essentially to, it's going to force us to have this kind of weird shift that goes on, if that makes sense. Let me think about exactly, before I do this, let me think about exactly how this has to occur, right? Because I think the pitch shifting makes it so that we have a problem keeping things aligned as nicely as we would like them to be aligned, if that makes sense. So maybe this is actually not necessary, what I'm doing. Or I shouldn't say not necessary, but it would mean that if we wanted to actually keep things aligned, we wouldn't actually be able to, like, we would not actually be able to do things in nicely aligned chunks. We would have to basically always read unaligned. So here's the reason I'm saying that, right? Is because if you take a look at how this is going to happen, if everything was playing at its normal 1-to-1 rate, then we're totally perfect, right? Because what would happen is, you know, you have a 128-bit read here and a 128-bit read here, and what's in there is basically 8 sound samples, right? Like 0, 1, 2, 3, 4, 5, 6, 7. And you have another one, 0, 1, 2, 3, 4, 5, 6, 7, right? And so as we come through, you've got the output buffer, and it's, you know, going along, and it's going to have, you know, L0, R0, L1, R1, L2, R2, L3, R3, and so on. And so when you're coming in, you're just loading in one of these guys, right? You're processing 8 wide, essentially. You're doing 2 4 wide paths, right? We do this half in float and then this half in float, right? And then we would output them into one of these buffers, and everything would stay nicely aligned as we played through, because the next time we, you know, the next sample would essentially be here, and we do the exact same thing again, aligned, right? But the problem is, if we are actually playing along at some other sample rate, so instead of 1.0, we're playing around at 1.9 or something like this, that becomes really problematic, because now, instead of advancing from here to here, the next one is actually going to be like from here to here, right? So it's gonna first do this, and then it's gonna do that, and so it's got this nasty problem where if I want to support that variable sample rate, I can't have things nicely aligned. And I can't really think of any real way I could avoid that, right? Like, if I want to support the pitch bend, it just doesn't seem like there's any way to keep it aligned. You're going to end up having to do unaligned reads from the sample buffers. And yeah, I don't know what we could do about that. So I wonder if maybe we just have to bite them. We have to bite the unaligned reads, and there's really not much we can do about it. And we'd always process 8 output samples at a time. But Yeah. I don't know. I don't think we can do it, guys. I don't think so. Maybe think about that a little bit, see if you can think about it, but it seems like we wouldn't actually be able to do that. And so I think we still want to keep doing roughly what we're doing here, but it does mean that it's never going to be aligned. So meaning this stuff right here is not actually going to be aligned. Samples to mix will still be aligned to 8s and we'll move along, but real sample remaining in sound, yeah, I don't know. This part's gonna have to be all unaligned and weird. So yeah, so I think that's just the way it goes. I don't know what else to do. So I guess we keep it this way. It's unaligned, but who cares? And we'll keep everything in multiples of 8 for now, and we'll see how that goes. So we've got samples remaining in sound equals, you know, whatever when we round this real samples remaining in sound. Again, this is all in units that are divided by 8. We then look to see whether the samples to mix, so that the 8 counts is going to stop early, and if so, we stop it early, like this. So we're really doing the exact same thing, just everything's divided by 8 now. We then do the same thing here with volume ended 8, and when we come through here, we've got both volumes end at the same time bug. Maybe we'll take a look at that at the end, but we don't really care about that at the moment, but we'd like to fix that to do eventually as well. Come through the channel indices, and let's see what we've got here. So we want to do exactly the same thing that we've been doing. We want everything to be on an 8 count now. So if we've got the delta volume, we have the target volume minus the regular volume. That's the difference, right? And then we've got the sample count. So what we want to do is figure out in counts of 8, how much is that going to be, right? So we would have the delta volume divided by the D volume here, and we'd round that out, right? But before we cast it down to a U32, what we would want to do here is, again, divide that by 8, right? So we would want to essentially multiply on the head end 1 over 8 to get that sort of contraction there, right? How do I do that? 1 over 8, 0.125, right? Like so. So we would want to do this. So now that's the volume sample counting, and again we do the same clamping that we were doing up ahead, right? I don't know why I said this was volume ended 8. That was kind of stupid. It's not. It's just a Boolean. All right. So then we come through here. We have our sample position, right? And that's going to be samples played, and we're going to again make that be an 8, you know, a multiple of 8 thing. The only difference is it's floating point. So really, when we multiply it out, we're going to actually respect its sub position instead of rounding it to a multiple of 8. So we're going to have to load unaligned from the sound, and that again is just to make sure that we can support that variable pitch. Right? So off we go. We take our sample index, and our sample index is going to be floor real 32 to int 32 of the sample position 8, right? We're going to multiply that by 8 to get it back up, and then we're going to floor it, right? So that's all good. That's all well and good, right? Frac works the same. We then have our samples here, and the samples are going to be done sort of 8 wide, if you will. And so what we probably want to do here is actually emulate that in our loop. So we can emulate doing them 8 wide, if you will. And then I'll kind of jump over that loop since that's the main thing that we got to work on here. Let's see. Let's do that. And then we'll fix this loop by moving it into SIMD, if that makes sense. So yeah, so the volume, right, is going to be something that gets incremented now by 8 times the delta volume, if that makes sense. In fact, I guess what we could do is this D volume, we could just have the 8 be multiplied into that, right? So that way, when we increment it as well, it works the same way, right? So we have D volume here. This is actually going to be D volume 8. So it's 8 times the rate of change that we were expecting to see, right? So yeah, I think that's good. And D sample would presumably be handled the exact same way. So this is actually 8 times the increment of the sample, right? So let's take a look. What else we got here? So this is divided by D sample. So I guess the problem with that, though, is that this calculation wants to know about that movement, right? It wants to know about this not multiplied by 8. It would seem, right? Because you want to know, because you've already pre-divided these guys by 8, which I suppose we could just not divide by 8, not pre-divide by 8. And since we're already dividing by d-sample, maybe this is just an excuse to say, oh, you didn't really have to change that. You still need to do the padding so you don't overrun when you do your wide read. But maybe you can just leave these guys as they were. I'm trying to think of how that would play out, right? But I think that would work, right? You could do it this way. And then that would produce real sample remaining in sound, right? I guess this should be samples remaining in sound. Yeah, I don't dislike that. That seems somewhat reasonable to me. Maybe it's just the intense heat here, but that seems somewhat reasonable to me. So, okay, we've got volume ended here. We've got this stuff working, delta volume. We're going to have to step through this a little bit more carefully and see everything, because I'm making a bunch of changes and sort of changing my mind as we go through things. And so that's always the case where you're going to have to kind of scrutinize it a little bit later, but that's fine. So we come in here, we've got our sample position stuff working the way that we would think. Samples played. If we were to actually make that be not divided by 8 now, we would end up with just sample position, right? And if d-sample 8 were d-sample 8, then that means that now sample position just actually is multiplied by d-sample. I'm sorry, just is moved by d-sample 8 and is just a regular value, and then we wouldn't have to multiply it in here. So that does seem like maybe that's just the smarter way to do it. I'm totally willing to believe that that's just a smarter idea there, right? So let's keep going with all of that nonsense. When we get to the end here, when we look at the current volume, we can still set it the way that we were setting it before. We can still do these endings the way we were doing before. Those don't change. We can still assert that the total samples to mix 8 is greater than the samples to mix 8 or equal. We can still say that the samples played equals the sample position. And we can still subtract out the samples to mix 8. This is probably more properly written like that. All right. So let's see. Playing sound samples played equals loaded sound sample count. That's all fine, and we could, as the samples played advances, it may advance past the end. So what we really want to say, if it's greater than or equal to the sample count, then what we want to do is see about that having that next one in there, right? Yeah. So that's also, I guess, sort of got the same issue that we would have had before. So we do have one other thing that's actually kind of tricky here. This is the exact same thing as our bilinear filtering without edges case, right? And I didn't even think about this. We actually had this problem before, and we probably just didn't notice it, but I think it would get worse when we were doing it in chunks of 8. So if you remember that when we were doing our bilinear filtering, we had this thing where we wanted to make seamless textures, right? Where we wanted it to be so that, you know, we'd have these things on the seam. If this is the seam, like we had, like this was a ground chunk, right? And here's a ground chunk. We had things where we had like two things, one on either side of the chunk, one in either side of a seam in different chunks. And what I was saying is when we were drawing this chunk, we didn't know what this chunk would actually be, and the bilinear filtering would fail across this edge. And so what we did to solve that problem, right, is we actually introduced an extra set of pixels along the edge, so that when you have A here, you actually insert B into the edge of the other chunk, right? And I think that's exactly what we would need to do here for those streaming chunks, right? What we want to do is make sure that we can blend over the edge so that when we take 8 samples and we're doing that by linear and we're stepping anywhere inside the 8 samples, we know that as we hit the end of one of our streaming sounds, we will blend properly between the two, right? So we would have had this problem before, right? If you imagine here is sort of a seam in the sound, if you will, right? So here's one loaded piece of the sound, and here's another loaded piece, right? And if you look at what's going to happen here, the same problem would occur. If here's a sample A and here's a sample B, when we would get to the end, if we were trying to sample from right here, we would pick up a 0 that was like the padding at the end of this sound's buffer, because that's just whatever's actually after it in memory. But what we wanted it to blend with was actually B, right? So what we want to do is pad the end of this loaded sample with whatever comes next, right? And so that's actually what would just automatically happen, right? That's actually what would happen if we just didn't do anything. And that's probably why it was working before and we didn't hear an error, although it may have just been because we never hit a case where you could actually hear it very well. Because since we were loading the whole sound every time since it was debug code, it would naturally have had that padding at the end of it. And so what we want to do here for padding, I think really in the asset stuff where we do this padding here, we do not want to do that padding, right? We want to leave that padding undone. And we have to just put a to-do in here, which is like all sounds have to be padded, with their subsequent sound, out to 8 samples past their end, right? We don't really care anymore about a line 8. A line 8 is simply not interesting anymore. What's actually interesting is, and I'll sort of get rid of this for now because, well, I guess we could do is say, in the case where we weren't one of those long-running sounds, right? What we would want to do is we would want to do this padding only in that case, right? In the case where we, in the case where we weren't doing it. So we can just go ahead and say we've got the actual result sample count in here. Go sample count. Sample count. And so when we're not in that, like we're loading out a little bit of a chunk, we would want to, we would want to do this. So you know what? I think we want to do it probably always if the end is us, if we are the end of the sound. So if the first sample index plus the section sample count, meaning where we would actually get to, is equal to the sample count, we're at the end of the buffer, right? Meaning we're at the end of the buffer. But that's going to be true no matter what happens here, because we're overwriting it. All right, so how do I do that? I think I do something like, I guess I just do something like if, add end. I think I just do something like this. Add end equals false. Or I guess I should say add end is probably always true, except in this case where we say add end is if we were going to be at the very end of this sort of thing that was streamed in piecemeal. So assuming that we're at the end of something, meaning either this thing was not a streamed in guy, so he's an entire sound in and of himself, or in the case where we are a streamed in sound but we're at the very end, what we want to do here is pad with the subsequent, we want to pad with zeros, right? Because the fact that we're loading the whole sound will take care of the padding in the other cases, but here we want to take care of that padding. Again, this will all be handled in the asset preprocessor normally, so we really don't care, but we might as well just try to emulate it to a certain degree here. So when we do this, what we'd want to do we want to do something like this, right? Where we'd say essentially the sample count, 8 past the sample count, we will pad that with zeros just to make sure that anyone who reads off there doesn't get any actual data. And then I think we're okay. I think that's really all we needed to do. Since we have to be unaligned all the time anyway, I think that's all we really needed to do. And now we can load right off the end, and that's fine. So let's go ahead in here and say uint32 sample offset equals 0, sample offset is less than 8, sample offset plus plus. Now we have a way to offset our sample. And so our sample index is always going to sort of be jittered. It's going to be, I shouldn't say jittered, but offset by whatever that sample offset is, if that makes sense. And so when we go ahead and do this here, I think everything else should be fine, I think. If we were using the other path, we could do that as well. And I think that's really it. So this would do that movement by 8 there, right? That would do the movement by 8 for us. It's all good. So let's take a look here. If d volume 8, what else we got? All right, so we've made a lot of changes there. Some of it's kind of janky. So let's see where we're at. Surprisingly, we still play sound. All right. So now that we're moving by 8s, it should be possible for us, right, to drop this portion into SIMD relatively easily, because this is all happening on actual 8s, right? So if you take a look at what's happening here, we're doing some fairly basic stuff. We've got some multiplies, we've got some writes, and we could start by doing the simpler case first. I'll go ahead and get rid of the bilinear blend for now, right? Or sorry, the linear blend. Right, so we've got just a regular case. So if we come in here, you know what, we also aren't really testing variable speeds, I suppose. So we could also say that dsample 8 times 1 point, you know, or 0.9 or something like this, right? Or 3.9f. Sounds a little janky. So I think we might still have some problems in there. Yeah, you can kind of hear. So I'm not sure that we've quite got that working properly, although I guess I also don't know how much we tested those guys before. Let me take a quick look at this one as well. Oh, duh. So sample offset here is actually not going to be correct, is it? Because the sample offset has to actually be a real value, right? So it's actually the sample index here, the sample position is what actually has to get changed, right? Sample position has to be, you know, sample offset, right, times whatever dsample would have been, right? It has to be just regular dsample like that. So that's why that was janky, right? Hopefully you can see what I'm talking about there. All right. So yeah, I don't think that's probably too much of a problem, and we have to deal with that in the SIMD stuff anyway. We have 15 minutes since we started late today, so ignore the Q&A begins now part of things. So there's the oops, I didn't want to duplicate that. I want to duplicate this. So yeah, so we've got that in both forms. Here we go. Still a little wrong sounding. So we've got dsample and we've got dsample 8. So that's all good. We've got sample index equals sample position plus sample offset times dsample, which is what I think it should be. We've got fractional value being what I think it would be, sample value. Yeah, looks relatively good. So I'm going to have to think a little harder about where that bug is. Yeah, so this part is not particularly interesting. We don't care about that. I think it's just this guy who's problematic. Let's see. When we update our samples played for samples position, that's all fine. So yeah, I'm not seeing it. I wonder if I'm staring right at it, but I'm not seeing what the bug is there. We want to do 8 samples at a time. We are doing that. We want to offset them by however much a single desample step is, which we are doing. But sample position actually needs to be, this is not actually correct here, right? Because this frac would be wrong. I don't think that's probably what's causing the problem, though. So this is offset sample position, I guess, right? Yeah. Yes, that's right. So there's our offset sample position, right? And then we would do it that way. And that looks better. Well, I take it back. That does seem to be what was causing it. All right. So at this point, I think we can drop this into SIMD okay. So what we would like to do in terms of making this work with SIMD is we've got a plus equals here. So obviously we're going to have an load PS to load in our dest, right? Again, just standard SIMD stuff that we're doing here. So we've got our D0, like so, and our D1. And we are going to have to load those guys in. Now, we're doing 8 samples at a time, so we actually have, I guess, something that's actually a little bit more confusing. We've got it looking more like this, right? We've got to load in more samples than that. We've got to load in 2 destinations because each one holds 4 floats, and we're doing 8 samples at a time, right? So actually what we're doing is we're loading something more like this, right? We're loading something, probably should write it like this, dest 0, 0, dest 0, 1, dest 1, 0, dest 1, 1. And of course we have to cast these to floats for reasons that only Intel knows. And so when we load these guys out, then after we are done loading them, we would do our work, and then at the end we would go ahead and add 2 to them, right? We would advance them by 2. And here's the work that we would do in there. So yeah, and then afterwards we would do, you know, after loading them, we would do something where we would store them out, like so. And again, these are going to be aligned loads and stores. Because unlike the pitch stuff, unlike what we're reading from, which cannot be, I think we've determined that probably can't be aligned, we can align all of these. These should remain aligned. I don't see any particular reason why they couldn't remain aligned always, so that should be fine. Yeah, so let's see. We'll do our loads from dest. We'll do our stores back to dest. I guess I gotta put some addressers in here. There we go. And our dest itself, we would like that to actually point to M128s now. We can get rid of that casting. And yeah, so those will be advancing by 2, which is 8 floats, which is 8 samples, which is how much we're doing them by. We can get rid of our sort of outer sample work there. And the volume and sample position stuff still would be advancing pretty much the same way. So now we've got this stuff in here that we need to do, right? We need to multiply by the volume. We need to multiply by the master volume. And then we would need to write it back. So we can do that pretty easily. I can just essentially do All of these guys could just be mul ps, and we would assume we have a master volume 4, essentially, that's replicated. I guess I'll just call that master volume. And that we'd also have a volume 4. Well, we'll do it this way. We can multiply these two together, and then we can multiply ps, the result, by whatever the sample value is, right? And that sample value, we would then add this in. So I guess I should probably call this a little bit something else. Let me think about how I want to do this. So we have the sample value, and then we're going to compute its attenuated version. So this is like the volume version, and then we're just going to add it in, right? We could do it all in one step. I just don't know if that's getting a little bit too verbose, right? But you can see I have to do the add as well, right? So I have to do an add, basically adding to D00, whatever the mul here is for these guys, right? So multiply the master volume by the volume, and that by the sample value, and that would give us the result that we would actually want, right? And this is pretty much all the same, right? So we would just need to now have these master volumes. The master volume is going to be in 2 flavors, right? There's going to be one for channel 0 and one for channel 1, I guess. And the volume itself is going to be the same way, right? So both of these have essentially two versions, one for the left channel, one for the right channel, right? So that seems reasonable, right? That all seems pretty good. And the sample value is the same in all cases, just gets loaded out. So really all we have to worry about now is loading the actual sample value, right? That's the primary part of it. And then we would have to worry about, of course, also getting these volume samples and all that stuff initialized properly. Okay. So if we want to do that, what we need to do first, I guess let's try doing it without the bilinear case. So in this case, we have to do this stuff, right? So we have to figure out what our sample value is by doing this round here. So we have our sample position, and our sample position, right, is now going to be something that's actually going to be 8 wide, if that makes sense. We're going to actually have sort of a sample position that's got 8 separate well, no, now that I think about it, we don't really have to do that. We'll be able to do only one load, but it's unclear exactly how we would want to index into it, right? This is kind of bizarre. So think about this for a second, right? What we know is we have a sample. Yeah, this is kind of ugly, actually, now I think about it. Because, man, the difference between when you're pitch bending and when you're not pitch bending is pretty drastic in terms of how bad it would be, how much uglier the code is. Uglier is probably the wrong word, but how much more work the code would actually have to do. So one way we could do this is by doing 16 separate fetches, right? But that's really kind of a waste. I'm sorry, 8 different fetches. But that's really kind of a waste of time, because most of the time, like let's say you're playing back at a speed of 1.0, all of the samples you want are right there in one single load. So it's kind of janky. It seems almost like we would want to actually special case that and have 2 different loops. One that does it, per sample or something for the pitch bend case, and one that doesn't. Because, man, the difference between those 2 is going to be vicious, right? Like, I'm just trying to think. If you imagine going at a rate, let's say you pitch bend it at a rate of 0.9 or something, right? Then the actual samples you're going to blend between are like, these two, these two, these two. I'm sorry. It's like those two, those two, those two, those two, those two, and then like those 2 again, and then those 2, and then those 2, and so on, right? So inside that loop, it's really kind of nasty because there's no way to really shift the buffers around. Yeah, I don't really know. And that's even in the non-bilinear case, it's kind of annoying, right? Because I do this load from the sound, and I guess let me draw it out explicitly. So here's the sound, and here are the samples, like so, right? And if I'm pulling from them at a rate of 1.0, I could just read this whole thing in and do ops on it directly. It's exactly what I want, right? I'd load this part of it into float, I'd load this part of it into float, I'd do my ops, right? And then I'd write them out to the buffer, right? So this is like float conversion here. This is like volume add, and then you store it, right? So it'd be super simple. It would just be really, really straightforward. But as soon as I introduce the concept that the speed might be different, then we get this problem of like, okay, even without linear blending, I might end up in a situation where this is what I'm reading, but what I want to actually operate on is like 0.0011122 or something, right? And that's just a really hard thing to make happen. I mean, it almost seems like there's just no way to make that happen any faster than just reading the things piecemeal out of the buffer, right? I mean, I really just don't see how you would do it. So, I mean, if that was the case, we could not bother going by 8s and actually just go by 4s, because if we're not able to load 8 at a time, then there's that. But you can see that's kind of nasty, right? That's pretty ugly, in my opinion. Yeah, that's really unfortunate, because it means that I just don't know if there's anything you could really do here that would be particularly clever without just special casing the loop a couple times for cases where you did know that you were doing relatively consistent reads from there. So yeah, so I don't know. So this part, really easy, right? That part is trivial. The other part, not so easy. It's at least not so easy to make go fast. What it would actually look like if we don't actually try to make it go through the SIMD path and just pack it at the end, we would essentially have something that looks like this. We have sample value, right? And that's going to be an MN set PS. And then what we would do is we would load the sample indices out here, right? Something like this, right? And these guys, obviously, we didn't quite do all of there. And yeah, it just looks like at that point you just don't care about 8s at all. 8s is just not that useful. You might as well go by 4s, right? At least I can't see any reason why you would. So anyway, yeah, you got these guys, and then you would just actually have to load them separately. You know, you would have to load them basically using this exact equation here. So I think I might actually just go ahead and copy that in, like so. What did that do? That is some weird piece of code. There we go. Oops. So we take the sample position, we load the sample office times the D sample, and that's actually the sample index that we would use. And we would have to literally do that and load it in order. So we would go like this. And I think that's just, you know, 0.0, 1.0, 2.0, 3.0. Right, so we would literally load those samples out like this, and then the second set would load it out like that. And yeah, just not, again, really kind of annoying. But I just don't really see, you know, just to be honest, I just don't see what the alternative is there, right? I don't know what we could do that would be all that much smarter than that. So let's go ahead and wrap that up. We'll think about this maybe for tomorrow, see if there's anything that we can think of that would be better. Where's my M128? There it is. So for setting these two guys up, right, our master volume and our volume 4, the master volume is always constant, right? It's not changing. So the master volume is easier. That's just whatever audio state master volume is. That's just a replicated value, right? That's an set1 PS. But the volume 4, this one is actually a little trickier because if you think about it, it needs to be ramping. Like the first value that in it, and it's actually operating. I guess I should jump over here. Let's see, to the whiteboard. If you think about what's going to happen there, right? You've got this volume, and in it, it's got V0, V1, V2, V3, right? Because we are multiplying by this guy, right? We're multiplying this as we go with our samples. So we'd have sample 1, 2, like so on, right? And when we multiply these down, this can't be constant because each individual sample is supposed to be ramping up or down its volume over time, potentially. So we need the values inside the volume to actually be pre-incremented. Like this should be the base volume level, and then it should go up by the D volume at each individual, at each location, right? So that when we multiply them together, we're getting a volume ramp in wide. So these guys actually have to be set PS to something that's a little more clever, right? It needs to be set to whatever the let's see here. We would need to do D volume regular again. Get that out. So D volume. And so in here we want something like the volume, and it would be the first one, right? And then I guess, oops, the first one plus nothing times the D volume, right? And then the next one is going to be 1.0 times the D volume, right? And then 2.0 and then 3.0, right? So it's like pre-stepped that volume ramp is, right? And so then when we come through here, and we actually do that volume addition, right? The actual volume, I guess, I don't know, do we actually ever use that what does that guy do? Yeah, so we actually do use it. We can probably just make it cheaper to extract this guy out here. But then what we would do is say, okay, we've got our D volume 4, and that's actually equal to, or I should say 8.4. We need a better naming. This is getting way too hairy for naming. If it wasn't the end of the stream here, we'd rename things probably right now. But anyway, so we've got the D volume like so, right? And we cut and paste these guys because we've also got the version for the other channel, right? So there we go. Yeah, we really need a good naming. We're gonna have to go through here and rename these. These names are awful. There's so many different permutations of things that we need some way of like making this naming a little bit more consistent. Now that we actually know what it is that we need to do. And we could simplify things a little bit by the fact that we don't have step by 8, but we have step by 4, so we're gonna have the same problem permutation-wise, if that makes sense. So yeah, so if we have these guys in here, I think that's pretty much all we would need to do. So in here we would have our volume 4, right? It gets added the same way, like so. And so those are actually tracked now, right? And the master volume, of course, like I said, doesn't actually ever need to be tracked in any way, although we do need to do both versions of him. Yeah. So, okay, let's see here. Oops, and these guys are obviously wide additions now, so those are MMAdd PSs. And there we go. All right. So yeah, not quite done yet, unfortunately, and we're 5 minutes over, so we got to end soon, unfortunately. But let's just make sure we left things in a semi-usable state. So we read all the samples out here and pack them in. We load out of the dest into 2 different channels and 2 different sets. We really need to switch back. Switching away from doing 8 is going to be crucial here to cut down on the nomenclature, since we know we don't need to do it anymore. So then we go ahead and do our moles here. It looks like these are correct, but this guy has to be done in 2 portions, right? This guy is actually devolume 40, if that makes sense. Or I should say, yeah, like this. This guy is actually that. It's an add of these 2, if that makes sense, because of the fact that we're stepping like we are. So again, super janky, and we could get rid of this. Man, sometimes I just hate programming on the stream because, you know, I want to like actually go do this properly. I want to remove the fact that we're going by 8s, and then I want to change all these names so they make sense. And I don't have the luxury of doing that on the stream, and it's very disappointing. So anyway, yeah, so let's see, I think that's it for that. Yeah, and it's kind of all annoying in a really annoying way. So I can drastically simplify all this. I just don't have the luxury of being able to do it today. And that's unfortunate, but you know, we'll at least try to leave things in a compiling state. They just won't be in a working state. So I think all that's good. We can do our multiply adds here. Those all seem reasonable. We track our volume still, which is correct. We advance our destination, which is correct. Yeah, we're just gonna not be playing anything reasonable. Yeah. Let's see. It wasn't as bad as I thought we were gonna be. I'll admit that. So let's go ahead and change it back to the normal speed. So you can kind of hear we messed up some stuff, right? Which is exactly what I would expect to happen, certainly. But again, we're completely out of time, so I'm going to have to leave it there. And then tomorrow what I'd like to do is go through here, remove the by 8 and turn it to just being by 4. Because, again, the only reason I wanted to do it by 8 is because I thought we'd be able to load 8 at a time out of the 16-bit sample buffers. But really, we can't do that because, I mean, we could only do that in a very specific case, which is where we're not changing the pitch. So that's unfortunate, but that's just the way it is. And so we'll go through and we'll remove that, which will clean up a lot of this kind of ugliness in terms of the notation. And then we can tomorrow go through it and actually clean up, you know, go carefully through the code now that we know everything that it actually is going to do. And that should hopefully help us as well clean, you know, get rid of some of the errors and that sort of thing, and debug it. So again, not in bad shape, but again, really wish we could just go another hour here, and then we could finish all this up, but we'll have to wait till tomorrow. And so with that in mind, we will put this episode to bed. And go to the Q&A. Yeah. So please, if you have any questions, prefix them with Q:, and I will answer them now. Yeah, hopefully, I mean, there really isn't much left to do here. We're mostly done. So really what we need to do is yank out the by 8 thing and then just clean up, you know, this stuff is typo-tastic, right? And so we just need to clean that up and make this not be so ridiculously weird there, if that makes sense. See if this is reading out of sample position. Yeah, so that reads out the samples by going along D-sample, so that's all nice. The volume stuff isn't changing right now, so I feel like that should actually not be really affecting us. So I'm not sure where our actual bug is, but I'm assuming that it will be relatively clear tomorrow where the bug is, if that makes sense. Oh. Thank you for someone on stream already caught one of the typos. These guys I didn't actually change when I put them in there. Oh, hey. I guess that was the primary problem. It's always nice to have people watching on the stream. They catch all my typos. It's pretty nice. Yeah. What's in the 8 bits we've been working on? Is it frequency and volume? Yeah, if you missed previous streams, so what we're doing in the sound sampler is we have D sample is the speed at which things are playing back. So it's basically, you know, the sample location. So that changes the pitch if you change it. And then volume is just how loud it is. Why is there a command override 0D with O, or it's OD and O2? So what's happening there is just that because we wanted to be able to keep the renderer running in optimize mode, because since the renderer does so much work and is carefully, well, not carefully, but is designed to run particularly quickly right now, we wanted to always run with it in optimize mode. So it's broken out in its own line here, and you can see it uses -02. And so I just wanted to keep using common compiler flags, which are set to either debug or release, one or the other. And then I just overrode it with an O2 so that only this one file gets compiled with optimizations. Can you skip the O.0 times D sample and only do 1, 2, and 3? Yes, you can, but the compiler will usually automatically remove that, so I usually don't bother. I usually leave it so you can see what's supposed to be happening there, if that makes sense. Not sure if it does or not, but that's the idea. Any other questions? Since we started late today, I guess it's a good day not to have too many questions because we can end on time. What does -OD do? That's not one I've come across before. It simply disables optimizations. So it's basically telling the compiler, don't do anything pretty much at all to the code, just literally straight translate it into assembly. And the reason that that's a useful switch is because it means that if you want to go look at something in the debugger, nothing has been moved around or optimized or changed. It's all extremely straightforward and does exactly what you typed in. And so when you're doing development, it often helps to have -OD on, because that means debugging is usually pretty easy. And we can do that for most of Handmade Hero because we don't have a lot of speed critical stuff in it right now. But the renderer just processes a ton of pixels, right? It's doing a huge workload. And so it needs to be on O2 all the time, or our frame rate at 1920 by 1080 isn't good enough. So, and that's what Handmade Optimized is all about, Gasto 5. It's just about making sure that the renderer, which does the vast majority of the work, is always built with O2 so that we get a nice fast 1920 by 1080 frame rate, and we don't have to constantly switch between debug and release build. We can always just have a debug build that's still fast enough. So. What do you think about the engine used at Overgrowth and its sound capabilities? I have not actually looked at what its sound capabilities are. So I don't actually know. I'm guessing that without specifying some sort of optimization flag, there will still be some optimizations done which you want to explicitly not do. Yeah, I mean, the idea behind it is just that you're specifying to the compiler, definitely don't do any optimizations, right? And so the compiler may have been defaulting to do some optimizations, or maybe it wouldn't be. I guess it could depend on the version of the compiler you're using, or what its default environment variables were set to, or who knows what, right? And so really all the -od does is it says, no matter what you were going to do by default, don't. Instead, just straight translate the code with no optimization thought put into it whatsoever. Gasto5, is this the last stream for audio? No, we got to clean up this mixing code tomorrow. And just set it up to go by 4s instead of by 8s. So we got to do that. But then we'll be done and we can go back to finish up the asset stuff, which really is just about memory management. And then we should be able to convert over to asset files, which would be really nice. Looking forward to that. That's going to be nice. So hopefully by the end of the week, we will have like an asset file format spec'd out. You know, something that we can say this is going to be how the assets are shipped from now on, instead of as like BMPs and WAVs. All right. I'm going to go ahead and wrap things up. Since we still got more work to do tonight, figuring out how we're going to do this whole GitHub situation. All right, I'm going to close this down. Save. All right, thank you everyone for joining me for another episode of Handmade Hero. It's been a pleasure coding with you as always. If you want to follow along at home, you can always pre-order the game at handmadehero.org, and it comes with a source code, so you can play around with it, learn from it, experiment with it, which is a good way to learn. You can also ask questions on our forum site and take a look at annotated episode guide, get ports to Mac and Linux, that sort of thing. We also have a Patreon page if you want to support the video series. You can subscribe there. And finally, we have a tweet bot which will tweet the schedule. So every weekend you can find out when we're going to be live that week. And it will also tweet during the day when the stream is coming up, so you can make sure not to miss it. So if you're trying to catch the stream live, that's a great way to do it. That's about it for today. I have a bunch of work I got to do tonight and probably all week, trying to figure out exactly how we're going to get community GitHub repository stuff going. We're trying to make that happen since enough people have requested it, but it's going to take a little while, and there's a bunch of things we have to sort out. But we're working on it, and hopefully there'll be some more news about that maybe next week or sometime soon. So thanks everybody who's been helping out with that. I really appreciate it. You know, I look forward to hopefully getting everything resolved so that there's something usable, at least as usable as GitHub can be, for people who want to work with the source that way instead of downloading zips. All right, everyone, take it easy, and I will catch you tomorrow, same time, same place, 5 p.m. Pacific Daylight Time. So until then, have a good one, and I'll see you online.